Welcome to this explainer. Let's dive right into the ultimate basement water battle. Today, we're going head-to-head, comparing sump pumps and ejector pumps to help you truly understand your home's plumbing and, more importantly, keep your property protected. So, if you've ever stood down in your basement, stared at a random pit in the floor, and wondered, what exactly is happening down there? Well, you are in the perfect place. Let's get right to it.
Picture this nightmare scenario for a second. It's 2 a.m., a massive thunderstorm is rolling through, and suddenly, you hear it, that dreaded splashing sound of water pooling on your basement floor. If your basement floods tonight, do you actually know which pump just failed on you? Was it the sump pump or the ejector pump? You know, for a lot of homeowners, these two pieces of equipment look pretty much identical, but they do vastly different jobs. Knowing which is which isn't just some fun plumbing trivia. It's literally the difference between a quick, easy fix and a catastrophic, incredibly expensive mess.
All right, let's lay down the baseline concept here. Honestly, at a glance, it is super easy to see why people get them mixed up. Both the sump pump and the ejector pump share the exact same overarching goal, moving unwanted water away from your building. But you really need to think of these two pumps like cousins. They work in the exact same industry, sure, but they operate in totally different worlds. They're built for entirely different plumbing setups, and they handle completely different sources of water.
To completely demystify these systems, here is our roadmap for today. We'll be covering 1. The setup. 2. Where does water originate? 3. Installation and operation. 4. The rules of discharge. And finally, 5. Keeping your pumps running. Okay, Section 1. The setup. Let's clear up some of the plumbing jargon they use in the industry before we look at the actual mechanics.
The very first term you need to know is below grade. This is basically any space situated beneath the surface of the ground, like your basement or a crawl space. And here's the thing. The absolute main enemy of below-grade plumbing is gravity. Because these spaces are underground, water simply can't flow naturally downhill to a street drain or a sewer line. Why? Because the drain is physically located high up above it. Which perfectly tees up our second definition, lift. Lift is the vertical distance that wastewater or drainage literally has to be pushed upward to reach that main sewer or discharge point. So the crucial takeaway here is this. If you have water below grade, gravity is working against you. You absolutely need mechanical power to create that lift. Both sump pumps and ejector pumps exist specifically to provide that lift, fighting gravity to push water up and out of your home.
Moving right along to Section 2, where does water originate? Let's trace the actual journey of the water itself to see exactly where it's coming from.
I want you to think of the sump pump as the tough bouncer of your basement. It handles groundwater seepage, stormwater infiltration, and condensation. Its one and only job is to keep uninvited outside rainwater far away from your foundation. Now the ejector pump, that acts way more like an elevator. It collects wastewater or drainage from inside your house, specifically from basement bathrooms, laundry rooms, or mechanical spaces, and it gives that water a ride up to the main sewer line. So simply put, one handles Mother Nature and the other handles your household chores.
Let's jump into Section 3, Installation and Operation. This brilliantly illustrates our next point, how those different water sources dictate exactly how these pumps are installed.
Because the sump pump is catching natural seepage from the earth, it's placed in a dedicated open sump basin, or pit, at the absolute lowest point of your basement. It's basically a big open catch-all for groundwater. But remember, the ejector pump is dealing with wastewater. We're talking dirty laundry water or even raw sewage from a basement toilet. Because of that, it requires a completely separate, fully enclosed receiving tank. You definitely want to keep those smells and sanitary hazards locked securely away.
Now, despite living in completely different types of housing, they actually share some pretty similar DNA when it comes to mechanics. Both of these pumps rely on float switches to turn on. As water fills up the pit or that enclosed tank, a little float rises. When it hits a specific level, boom, it flips the switch and tells the pump, all right, time to go to work. Both of them also utilize check valves. These are essentially one-way doors that stop the water they just pumped out from flowing right back down the pipe. And of course, both require highly reliable power to function properly. That is exactly why you'll always hear professionals stressing the importance of battery backups for these systems.
All right, Section 4, the rules of discharge. So once that float switch triggers, where does all this water actually go?
The absolute biggest practical difference here is the plumbing route they take to get water out of your house. For a sump pump, the goal is pretty simple. Just get that relatively clean groundwater far, far away. It routes the water to a storm drain, a dry well, or just a sloped area of your yard where it won't run back into the building. The ejector pump, however, is lifting dirty wastewater.
It has to use serious pressure to push that waste upward to a main sewer or drainage line that's physically too high for normal gravity flow. It absolutely must tie into the city sewer or your home septic system. You cannot safely or legally just pump that out into your front yard.
And here is something really fascinating to think about: the sheer workload. Moving wastewater is a seriously heavy-duty job. We aren't just talking about clear rainwater anymore, right? Ejector pumps might be moving laundry lint, heavy soap scum, or solid waste. Because of this, ejector systems are often configured for higher duty cycles. That means they just have to work harder, run more frequently, and endure a lot more daily wear and tear. They also require highly specific piping arrangements, including dedicated vent pipes to safely route harmful sewer gases all the way up and out through your roof.
Which brings us to our final category, Section 5, keeping your pumps running. Let's talk maintenance for these basement heroes.
Think of this slide as your mental side-by-side cheat sheet. When it comes to basic maintenance, both pumps absolutely require a freely moving float switch. If that float gets jammed against the side of the basin, the pump is never going to turn on, and you are going to flood. Simple as that. But their specific differences really dictate how you care for them. A sump pump requires you to confirm that the open pit is completely clear of debris, and you need to check that the discharge line outside isn't frozen over or blocked. An ejector pump, because wastewater is inherently messy, demands some extra TLC. You need to do periodic inspections of that check valve to make sure solids aren't jamming it open. You've got to monitor its performance when you're doing heavy laundry. And crucially, if your enclosed tank has a high water alarm system installed, you need to test that alarm regularly.
Which leads us to this absolutely fantastic piece of advice directly from our source material. Quote, if you're replacing equipment, a licensed plumber or qualified contractor can confirm the right pump type by checking the water source, piping layout, and required head pressure. This is your ultimate bottom line rule of thumb. Figuring out the correct head pressure, which, again, is the mechanical power needed to achieve that lift we talked about earlier, and configuring a properly sealed piping layout, that is definitely not your typical weekend DIY project. Because if you install an ejector pump incorrectly, you aren't just dealing with a little puddle of water, you are dealing with a severe, highly dangerous sanitation issue right inside your home.
And that brings us to our final thought for today. We've traced the water, we've explored the pits and the tanks, and we've completely broken down the mechanics. So, knowing the vital difference between groundwater and wastewater, I have a question for you. Are your basement pumps actually ready to handle the next heavy storm or a marathon laundry day? Seriously, don't wait for that 2 a.m. thunderstorm to find out the hard way. I highly encourage you to head down to your basement today, take a good look at your setup, and figure out exactly what kind of system is actively protecting your home. Thanks so much for joining me on this explainer, and hey, happy inspecting!